Howdy everybody, here's the walkthrough of my code for my treasure chest. At the start we got some general task description things, my name, project, my overall goal that I started this project with, and then some of the specific subparts I wanted. I got my initializing all my variables. I have to set up my servo, give my servo a name, I called it my servo, and I tested a little bit and found that value of 0 made it so it was in its locked position, the value of 70 made it so it was open. I set up my little bank for this is where when you put your 4 numbers in, it saves them here in the first, second, third, and fourth digit. This was that first code that opened the safe, defaulting to 1, 2, 3, 4, and again you change that if you went into the master, and that was that 9892 number. So that's how they all start. Starting all my variable pins with my servo into digital 11, my RGB LED is into 10, 9, and 8, my potentiometer is plugged into analog 0, and then my button is connected over to digital 2, and a delay. Setting up, I set up my servo, I set up all 3 of my LEDs and my button as an input, and I set up my serial begin. This is what allowed me to do all my debugging. This is also what prompted the communicator over here to display all the words and numbers I was having it display in the previous video. Okay, so as far as the actual loop, I'll note it's very short. I start the servo out locked, and then I just have it checking the button, reading the button, and getting the button's value. As soon as the button is pressed, as soon as it goes to low, the code executes the code let go, new input, and check input. Now I got a whole bunch of secondary functions down below. We're going to kind of go through what each of them do. We'll start with the main ones and then kind of hit on the less important ones at the end. So let go, this is kind of with the digital dice project from last week. I made a code that essentially waits for me to let go of the button before going on to the next line of code. So I was having the same issue where if I press the button for too long, in addition to checking it here, it would start executing all this really, really fast. And so this let go button is going, or function is going to appear a lot, and all that's doing is making the code just wait until I let go of the button before it goes on to the next line. So then our first main code is new input. So under new input, this one I make an index variable, and basically I have it just run this code 4 times. And all this code does is it executes this command, get number, 4 times. So for the first number of our access code, for the second, the third, and the fourth number, it just repeats it 4 times, and then this is where it printed the access code that we entered after the end of that new input part. Let's go look at that get number, because that is probably the most important part of my code. So we'll scroll on down here. Or is it here? It is get number. And so get number, I initialize the potentiometer, the button, just like we have before. I make a new variable called stored using translate. This translate function we'll get to in a little bit, but basically all that does is it translates the potentiometer's values, which go anywhere from 0 up to 1023, to my 0 to 9 little dial that I'm trying to use here. So that's all translate does, translates it into 0 to 9 numbers, and then also a current value. And then I measure the difference between the two. We'll get to that in a second. At that point we get to this while loop. In this while loop, it's basically waiting until I press the button, so until I press the button to store the value. Keep reading, or keep checking if the button is pressed, go get the value of the potentiometer, translate that value of the potentiometer into my 0 to 9 range, and then calculate the difference. Basically all this is doing is if my potentiometer is at 3, and I don't do anything, and it stays at the value of 3, this difference would be 0, and then nothing would change. If I move my potentiometer up a little bit, so we can see that over here, my value is at 9, it stays at 9, but if I change my potentiometer a little bit, and it recognizes there's a difference between the previous value and the new value that my potentiometer is at, it indicates now, okay, my value has changed, now it's at 8, and so if I'm happy at 8, I would press the button, and that stored it just like I did in the previous example. Repeat that 4 times, and that repeating 4 times is back up in my new input, repeat 4 times, and so now it has stored my code. In this case, it's stored as 8888. Now after we have the code, the next important part is let's check the code to see, is it a master, is it the correct code to open the safe, or is it a wrong code? That's where we get to our function check input. In here, I have checked to see if it's the master, if all the bits, so if the first number lines up with the master's first number, if the next number lines up with the master's next number, and so on and so forth. If all of the numbers match up with the master, then that has a go and say you've entered master mode, and it goes into the master reset function, which we'll get to in a minute. Second option is it checks it, and if it currently matches the correct code, the first number and the second and third and so forth, then it says congratulations, the correct pin. It moves the servo to open, it turns on the green LED, and then last but not least, if it's the wrong code, then it just turns on the red LED and says, sorry, wrong code, press button to try again. And after all those, I have a little wait here, where all it's doing is waiting you to press the button to move on with the code, at which point, again, that let go, just to make sure it waits for me to let go of the button. And then it turns the servo to locked, turns off all the LEDs, basically just resetting the box back to how it originally started. Now, as far as the master reset, this is basically identical to the first loop where I put in the numbers to for my code, but essentially now instead of changing my code, it's changing what is the correct combination that I've titled yes code. But basically the same function, just now it's overriding the correct code to get in, as opposed to just putting a code in to test. As far as these last couple at the bottom, we already looked at get number. That's how it's reading the potentiometer, showing the value over in the debugger window, and prompting me to accept the answers. Here's let go. It's pretty short. Basically just saying, while the button is pressed, do a little wait. And it just repeats that until I let go of the button. And the last part is to translate. And so I've determined that if the servo went from 0, or the potentiometer, excuse me, went from 0 up to 1023, then if I divide that by 10, it's about 102. So I said for the first 102 numbers, so going from 0 to 102, that's going to correlate to the output value of 0. For the next, so going from 102 now up to 204, I'm going to say that's the value 1. Next, up to 306, that's the value of 2, so on and so forth, up until anything above 918, up to 1020 would give me the value of 9, and then it returns that result. Overall, this code took a lot more functions than I thought it was going to, but the nice thing with functions is I made this little line of let go, which was, I don't know, about 10 lines long by itself, but I used this probably 4 or 5 times throughout my code, and so it was nice having it there. I could just type in the code let go, and it would run that every time reliably.